Hi, my name is Sammy, and in this video I'm going to show you how I made my first EMACS package. I'm a big believer in learn by doing, so this will read more like a story than a technical manual for EMACS Lisp. I actually didn't even know EMACS Lisp when I started. I never read the full documentation, so if you're following along in this tutorial, you'll be in about the same place that I was when I first started. Also, as an engineer working on a project, you'll hear this phrase a lot. Just read the code base, or the code is the documentation. When I first started out as an engineer, I didn't really understand what that was or what that meant. And so I'm hoping by following along with my process and kind of coding along with me, you can get a sense of what it means to actually do that and to learn how to program by reading somebody else's code base. As a result, this is kind of a longer video because I'm hoping that you'll kind of learn and discover alongside me. But I think the content is really good and that following it will be really useful in understanding the engineering process. I'm going to follow roughly the following format that I like to use when working on projects. So first, I'm going to find something that I don't like. Then I'm going to figure out what the ideal UI should look like. So if I was a perfect programmer and I could build anything I wanted, this is what it's supposed to be. Then I'm going to look for code examples or projects that do something similar. Mostly not to really copy paste stuff, but more to learn Emacs Lisp and to learn how Emacs packages, especially in this area, are being built. And then I'm going to write specific steps for, like what specifically do I need to change from the current state to the future state to get to my ideal UI. And then lastly, I'm going to use my understanding and code examples and try to build it. So first up, have something I don't like. I'm actually very good at this, but when I started this project, I had one thing in mind, which is switching buffers. So I switch buffers all the time. It's one of the things that I do the most within Emacs. Like I use it as kind of like a window slash like environment management system. And every time you switch buffers in Emacs, you have to do this thing where you hit Control XB, and then you type out the full name of the buffer that you want to switch to. So actually, let me disable my package first. Give you kind of a preview of what we're doing here. And every time I switch buffers, so every time I do Control XB, I have to type out the name of the buffer that I want to go to. So in order to like, if I wanted to switch and go to the scratch buffer, I would have to type out, scratch, and then hit enter in order to go to that buffer. Now there's some things that we can do to like make this faster. So if you hit Control XB and then just enter, it'll go to the most recent buffer. There's also tab completion. So if I start typing messages and then I hit tab, it'll know to go to messages because messages is the only buffer that starts with star messages. But this has always been like kind of painful for me because a lot of times I'll have open a bunch of buffers like, my Java file test, and then I'll have open my Java file, uh, my Java file, and then I'll have open my new Java file, right? So I'll have a bunch of these files open that all have sort of similar names. And then when I go to do tab completion, I'll start typing my, and then there are like 4 different completions. So then I'll type my Java, and then there will be 2 completions, and then I'll have to keep going, I even messed it up. I'll have to keep going through this process of like typing the beginning of the buffer name, tab completing it, and then typing the rest of it. And it's always been like super annoying to me, especially because I tend to name a lot of my files with the same prefixes, just because, like I'll start with like the namespace and then I'll add stuff to it. And so it's really annoying because I'll often wind up with a bunch of these similarly named files. So next up, we need to figure out what we want the world to look like. So ideally, in a perfect world, what should happen when I go to switch buffers? And so the thing that I personally want is I want it to be that whenever I enter switch buffer, so whenever I hit Control XB, I want selecting which buffer to jump to be a single key press. So, I don't want to have to type part of it and then hit tab. I don't want to even have to type a letter and then hit enter. I just want it to be like one single key press, immediately go to the tab that I want to open, and then be done with it. So basically, the way that I thought about doing this was assigning the keys 0 to 9 to the 10 most recent buffers, and then hitting the 0 key goes to the most recent buffer, hitting the 1 key goes to the next most recent buffer, etc., all the way up to the 9 key, which goes to the, I guess, 10th most recent buffer. So the key idea here is that if we want picking a buffer to be one key press, that means each open buffer has to correspond to a unique key. So obviously, if you have 100 open buffers, there aren't that many keys on the keyboard, but we can do this for the 10 most recent buffers. I picked the keys 0 to 9 because I don't usually switch between more than 10 actively used open buffers, and I also don't tend to start my file names with numbers. So if you use a lot of numbered file names, maybe use a different key system, but this is one that worked for me. Now, as part of this, I also can't remember which buffers are my 5 most recent, so I'll need a little menu that shows me kind of which buffer corresponds to which button. Because, if I have to count the buffers or remember, God forbid, all of the buffers that I recently went to, then I'll have no idea how to choose the right one. Now, at this point, I still don't know anything about Emacs Lisp or Emacs development. So to get literally anything started, I'm going to have to look at some code examples and other projects for inspiration. To do this, I literally just Googled packages for switching buffers for Emacs, and I tried to find packages that were doing something similar to what I was trying to accomplish. So I dug around a little bit, and I found two packages that were both sort of designed to improve the buffer switching experience, which were ido-mode and ido-vertical-mode, which is like a little mode that builds on top of ido-mode. So ido-mode, basically, if you're not familiar with it, it's an EMACS package that adds interactive completion to buffer switching and a few other things. And its main feature is that it shows a list of possible completions for the buffer name while you type, so that you can see kind of what all your options are even before you hit tab. And then if you do hit tab, instead of simply completing the buffer name, if there's only one possible completion, then it immediately jumps to that buffer. So it's like a little bit faster than the previous behavior, but it still keeps kind of mostly the same style. So what I did is I actually went online and I found the code, like the .l file for the package, and then I just started reading through it to see what it was doing and how it was doing things. So to give you a sense of what I did here, let's open up the file and let's take a look together. So the first thing that I did is literally just skim through the file. I sort of like quickly read the comments on the top, but really just like, quickly just scrolling through the file to see like roughly what's in it and see how it's organized. And so, this was like an hour or two of like looking and digging around, but kind of the main things that I saw were roughly how it's organized is it has at the top, like the very first thing at the start of the file is a bunch of customizations. So these are like, if you're already using ido-mode and, you want to set up customizations to make it work slightly different, these are all like the custom variables that you can set. And then below that, there's a bunch of def vars, and so these look like they're sort of different from the customizations in that they're not really meant to be as set directly or interacted with by the user. These look like the variables that are used internally by like the ido-mode package, and then all the way at the bottom we have like a ton of function definitions and kind of things that are doing stuff. And this looks like it's actually the bulk of the work that's being done by the ido package. So just kind of just quickly skimming through it, we see like there's a bunch of customizations at the top, then a bunch of variable definitions, and then like a bunch of function definitions that look like they have most of the main functionality. Next up, I tried to find like functions and variables that looked relevant to kind of the things that I was trying to accomplish. So some of the things that I found were I found this ido-completions, which supposedly returns the string that is displayed, so basically what goes into the mini buffer, which I thought could be useful to what I was trying to do. Um, then also inside of ido-vertical-mode, I found this little function which looks like it's setting up all of the key bindings for the mode, which should be useful to us because we want to set up some custom key bindings. And then I also found this function that looked pretty interesting that basically returns the string that's displayed after the user's text. So again, it looks like this is figuring out what goes actually inside of the mini buffer. So now to actually figure out where to go from here, let's actually read this function and try to see if we can figure out what it's actually doing. So I actually decided to go through and read this function in detail, line by line, to see if I could really understand it. Now, since it's not too much fun to watch, I'm going to give you guys the fast version, but I really did go through this very slowly and very carefully. So at the top, we have a let statement, which I know from my other Lisp experience is basically just a bunch of variable definitions. So this is setting comps to ido matches, which I understood to be the list of current buffers that match the string that the user has already typed. Then I have no idea what this does, but it looks like it's setting some index. This is setting length comps to the length of the completions. This is setting some indicator that's used, it looks like when there are too many items to display. It looks like this comps empty checks whether comps is empty. It looks like we're setting something to the length of the completions again, but probably because we're going to modify it later. Now let's take a look at the rest of the function because there's really a lot in here. It looks like what this does is when there is enough space to display all of the possible completions, we don't need the new items indicator anymore. So we just set it to a new line, which kind of empties it out. And then this says when ido pad list is set, we also want to make the list include a bunch of empty items at the end. So basically, when pad list is set, we increase the size of the completion list and we add to it a bunch of items with the empty string. Next up, I saw that all of these statements depend on some form of ido use faces. So this depends on ido use faces. This depends on ido use faces, which isn't something that I think I really care about for this. So I didn't really look at these too closely. Then next up, we have this ido vertical count, which looks kind of interesting because part of what we want to do is put numbers in front of all of the possible buffer completions. And so what this is doing is it's setting some variable vertical decorations, and it's adding to it format lane comps. So basically what it's doing is it's adding some string representing the length into some decoration that somehow gets displayed in the output. I'm not 100% sure what this is doing, but it looks like it's doing something similar, except removing the information, but I'm not 100% sure what's going on here. Then it looks like we have another block that depends on ido use faces, which isn't relevant to what we want to do, so I'm going to sort of skip it. So this function right here looks like it's doing the bulk of the work, so let's look at it in a lot of detail to see if we can figure out what's going on. So we have this condition statement, and the condition is actually what's being returned by the function, which if you look up here is the string that is displayed after the user's text. So this condition statement over here actually returns whatever string gets displayed after the user's text. So first if the completions are empty. So if there are no possible completions remaining, it shows some sort of message representing what could happen if there are no possible completions. So like, you know, you could get a confirm, you could get that the input size is too big, or like a bunch of other stuff, or I guess just like an empty string. But this is basically just what should happen if there are no possible completions for the text you entered. Next, if you entered an incomplete regular expression, it looks like it just shows you the first possible completion, which is kind of interesting. I didn't know it worked that way. Next, if the CDR of comps is null, so basically if the rest of the completion list is null, i.e. the completion list has only one item in it, it even says this over here in a comment, then we basically just print out some text to show that you've matched with this particular item. And then last up, if true, so this is the fall through case. So this is basically like if the completions list has anything else in it, then we do this big block of code, which remember still returns the string to be printed into the mini buffer. And so it looks like what this does is it loops through all of the possible completions, and then it collects them into a list, and then it concatenates them all together, separated by this ido decoration string. Oops, separated by this ido decoration string. So the output is the string that contains some decorations, as well as this alternatives variable that holds a list of all of the possible completions separated by this ido decoration string. So now that we've dug through this method in detail, let's take a quick look and see where it's used. So I'm going to search for ido vertical completions, and I see that the only place that it's used is in this ido vertical or horizontal completions, which looks like it's just wrapping it with a little bit of extra logic. So now I'm going to look for this string, and I see that this function is used only over here. So let's take a look and see how this function is actually being used in the codebase. So now let's take a look at ido vertical turn on and see what this is doing. So it's taking ido completions and it's storing it in ido old vertical completions, and then it's resetting ido completions to this new variable ido vertical or horizontal completions. So basically what it's doing is it's taking the old behavior and then caching it somewhere, and then it's overriding ido completions to be this new function. And so this gave me an idea. Ido vertical completions is a lot of code, and I don't really want to copy and paste that much code around, let alone try to dig through it again myself. And so I thought, what if what I do is I take the old behavior of ido completions and I cache it in a variable somewhere, and then I set the new behavior to call the old behavior and then do some additional stuff to it. And so that's kind of the strategy that I ultimately wound up using, and you'll see that a little bit later when we actually go through the design and write some code. In addition, ido vertical turn on also does a couple other things. It looks like it disables line truncation, and importantly, it also calls ido vertical define keys. So it basically calls this function over here, which sets up all of the, I guess, like special local key bindings for ido local mode. And then just to close it out, we can also find the overall entry point to this code, which looks like it's right here in this sort of method slash mode definition, ido vertical mode. and it looks like it calls this function ido-vertical-turn-on. So basically, this is the thing that sets up ido-vertical-mode, and then it calls our function that we just looked at. And then if it's already on, then it calls this other function to turn it off. So now that I had a rough understanding of similar and relevant code and a pretty good understanding of what I wanted to build, now it was time to come up with the specific code changes that I needed to make in order to get from point A to point B. So in order to make this work, I needed to do two things. I needed to add key bindings so that pressing a number key goes to the nth buffer, and I also needed to update the bottom display such that alongside each buffer name, it also shows the number associated with that buffer. Let's tackle the key bindings first, since it's easier. In order to do this, I need a function that takes as input a number n and goes to the nth number in the list of IDO completions. Digging through ido-mode.l, I found this function ido-next-match, which goes to the next match in the list of completions. I actually want to go to the nth match, so in order to get there, I call this function n times and then return the result. I added a boundary check to make sure that there are at least that many buffers. I exit the mini buffer when it finishes running, and I added an if statement so that this only happens on the first character entered. Otherwise, it would be difficult to type out file names that have a number character in the middle or the end of the file. I also needed to add this interactive keyword to let Emacs know that this function can be called directly from a key binding. Next up, we need to actually define the key bindings for the numbers 1 through 9. I left out the key binding for 0 because you can go to the first selected buffer if you just hit enter. I looked at how ido-mode and ido-vertical-mode were doing this to make sure that I built this map in the right style. Next up, we need to update the mini buffer to display the numbers next to each of the possible buffer names. Using the caching in ido-vertical-mode as inspiration, we need to create a function that takes as input the current display string and returns a new string with the numbers attached. I had no idea what delimiter would be used or how ido-mode would actually render the string, but I knew that the matches would be in order, so I used the following strategy. Search for the next match, add the next number to it, and then recur on the rest of the string. I'll show you an example. So let's say we have the following input string and the following list of matches. What we do is we start with my first buffer and we try to find my first buffer in the input string. So it would find it over here. Then we would take this, we would add a 0 in front of it, and then we would recur on the rest of the string and the rest of the matches list. Then we would look for my second buffer in the input string. It would find that here. It would add a 1 in front of it, and then it would recur on the rest of the string and the rest of the matches list. So I'll just show one more step very quickly to make sure everybody understands this. So in the next step of the recursion, we would have this string and this input list, and then we would add a 2 in front of my third buffer. Specifically, do we want in the recursion step? Well, we want to return a new string that has everything before the first match. So that would be this little piece right here. Then the number that goes in front of it. So that would be this number. The name of the match itself. So that would be this piece right here. And then the recursion step applied to the rest of the string. So that would be whatever the result of this evaluation is. All right, so let's see if we can actually go ahead and build it. So first we need to find the match in the input string and get the components that are before and after it. That's what the split once function does. It's a little helper util I wrote that works sort of like a Java or a Python split. It's pretty simple, but I'll go through it in more detail later. The result here is pretty simple. It's a 2-element list that contains all of the stuff before the search string and then all of the stuff after the search string. So what do we want to return? We want to return everything before the first match, the number that goes in front of it, and a little space, the name of the match itself, and then the recursion applied to the rest of the string. So the rest of the string is the second result from our split once function that we already talked about. Then we want the rest of the matches. So CDR in EMACS Lisp is the way to get the rest of the list after basically remove the first element of the list and get the rest of it. And then we want to increase the current number that we're talking about. And so that's it. That's like the main idea behind what we're doing. Now, if you're paying attention, you probably realize that we also need a base case. So we want this function to stop when you get to the end of the input string or when you've already counted up to 9 numbers. We also want it to stop if there are no possible matches left. I promised we'd also quickly go over split once, so here it is. It just searches for the search string in the input, and then it returns the substrings before and after that location. Lastly, we also have to call into the recursion function with its initial arguments, namely the input string, the list of current matches, and 0 to let it know to start at the number 0. We just need to make this into a real package. So we follow the example of ido-vertical-mode to create functions that turn this behavior on and off, using the idea of caching the current behavior of ido-completions, and then wrapping it in a new function, and then calls into our add numbers function that we just made. We also revert this by setting ido-completions to its old behavior, and removing the hooks to define the keys. Also following the example of ido-vertical-mode, we create a mode function that we use to turn this behavior on and off. In order to use this, you just require the package and then turn on the mode. Now let's reopen Emacs and marvel at our work. Now if I go to switch buffers, you'll see at the bottom a lot of little numbers from 0 to 9, and if I hit one of those numbers, let's say I want to go to the messages buffer, then I can just type 8 to go to messages, and it'll go immediately to the messages buffer. I've been using this package myself for almost a month now, and I absolutely love it. Thanks so much for watching, and as always, remember to like and subscribe for more quality content.